Today we're going to talk about the transfer function of a complex circuit via mesh analysis. So this consists of multiple loops of meshes. So we have an example given the network of figure 1. So this figure, find the transfer function I sub 2 as a function of S over the output voltage as a function, or the input voltage as a function of S. So this is the given circuit where, as you can see, we have two resistors R1 and R2. We have an inductor and a capacitor components. So in order to find the transfer function of this circuit, we have to transform the circuit, where we have to replace the components with its Laplace transform. So the Laplace transform of the resistor, the voltage source, the inductor, as well as the capacitor. So as we all know that the Laplace transform of the inductor is just Ls, and then the capacitor is 1 over Cs. So the input voltage is a voltage as a function of S, and also the current is a function of S, where the components and the parameters are now in the S domain. So in order to find the transfer function I sub 2 as a function of S over V as a function of S, we have to follow the pattern. So as you can see, we have a pattern in order to find the transfer function. So the coefficient of I sub 1 as a function of S, it should be the sum of impedances around mesh 1. So this is the mesh 1. This is the first mesh. So we have to add the impedances around mesh 1, then minus the sum of impedances common to the two meshes, and then equal to the sum of the applied voltages around mesh 1. So the second equation is the sum of impedances common to the two meshes, and then plus, so this is negative, and then plus the sum of impedances around mesh 2 equal to the sum of applied voltages around mesh 2. So let's answer this problem. So we have, okay, let's solution. So we have to find the first equation. So sum of impedances, as you can see, the sum of impedances around mesh 1 is, so second, this is the mesh 1. The sum of impedances around mesh 1 is R1. So this will be R1 plus the impedances of L. Oh, this one rather, L of S. So this will be Ls times I sub 1 as a function of S minus sum of impedances common to the two meshes. So there is only one component that is impedance that is common to the two meshes, which is the L sub S. So therefore this will be L sub S I sub 2 as a function of S equal to the sum of applied voltage around mesh 1. So the total voltages around mesh 1 is equal to V sub S. So this is our equation 1. So for equation 2, we need to use this pattern where it's negative sum of impedances common to the two meshes. So this is uh, same Ls. So this is Ls common to the two meshes. So this is Ls times I sub 1 as a function of S plus sum of impedances around mesh 2. So there are three components, Ls, R2, and 1 over Cs. So three impedances. So therefore, this is R sub 2 plus Ls plus 1 over Cs times I sub 2 as a function of S equal to the sum of applied voltages around mesh 2. So by KVL, so the sum of all voltages in mesh 2 should be equal to 0. As you can see, we have now two equations, two unknowns, where we can find the unknown variables, but this time we have to find the transfer function, the ratio between I sub 1 and I sub 2, and the voltage as a function of S. So where we can find, so by Cramer's rule, so we can use Cramer's rule, or we can convert this one to a matrix. So in matrix form, this will be R sub 1 plus LS, then minus LS, then this will be minus LS, and then this is R2 plus LS1 1 over CS, and then I sub 1 is a function of S, I sub 2 is a function of S, equal to P is a function of S, and then 0. So this is in its matrix form. So by Cramer's rule, we can find the transfer function. As you can see, if you want to find I sub 2 as a function of S by Cramer's rule, the formula will be, so this coefficient, so this will be the this coefficient. So since this is I sub 2, so the coefficients R1 plus LS and negative LS. So therefore, by Cramer's rule, this will be R1 plus L sub S minus L sub S, and then the constant V is a function of S and 0 divided by the delta. So by just a quick review, no? If you have a sub, wait, so just a quick review. So for Cramer's rule, so if you have a two equations, no, a sub 1, a sub 2, you have two unknowns, x1 and x2. So as you can say, x2 is equal to d sub 1 over d, and then x sub 1 is equal to rather d sub 2, this will be d sub 1. X sub 1 is equal to d sub 1 divided by d by Cramer's rule, where d is just equal to the coefficient matrix a sub 1, a sub 2, b sub 1, and b sub 2, where a sub 1 times b sub 2 minus a sub 2 times b sub 1. So that is the d. So to solve for x sub 2 is just equal to, to find d sub 2, you just get the coefficient of the x sub 1. So therefore, a sub 1, b sub 1, and then the coefficient, the constants, the constants na yun, divided by this one, the d. Then to fit the constants na yun, divided by this one, the d. Then to find for x sub 1, this will be c sub 1, c sub 2, a sub 2, b sub 2 divided by d. So in our previous example, the transfer function, this is how we do the Cramer's rule. So this same Rashani, no? Rashani. So instead of using the capital D, we are using the delta because we are following the variables of the book. So if this is I sub 2 as a function of S, where, so we take, so therefore this will be R1 plus L sub S times 0, so this is 0 minus negative This is negative ls times v as function of s divided by the delta. So this will be plus, so ls v of s divided by delta. So therefore I sub 2 as a function of s is equal to ls v is a function of s over delta. So what we are going to find is the ratio between I sub 2 as a function of s and the v of s. So if you take the ratio, so I sub 2 as a function of s divided by v of s. So therefore, we can find the transfer function by finding this ratio, ls divided by this one, divided by the delta. But this time we don't have we have to find the delta first, no? In order to find the transfer function. So the delta is just the coefficient matrix, no, of the mesh. So okay, let's find the delta where the transfer function is just equal to I sub 2 as a function of s divided by v as a function of s, where it just equal to, by Cramer's rule, we calculated that transfer function is just equal to ls divided by the delta, where this is ls, where the delta is just equal to the coefficient matrix, which is this one, where just copy this one, r sub 1 plus ls negative ls, this is negative ls, r sub 2 plus ls plus 1 over cs. So so by Cramer's rule, so this will be L sub s divided by, so this will be r sub 1 plus L sub s times kr1 plus ls times r2 plus ls plus 1 over cs minus um, l squared s squared. So this will be, so how about we take out the cs, no, by using common denominator. So this will be um, ls divided by r1 plus l sub ls times, so how about we take the common denominator of this terms, so this will be r sub 2 plus ls plus 1 divided by cs. So this will be cs and then I cs drop, by the way. So minus l squared s squared. So this is equal to ls. So we take the common denominator of these terms. So therefore this will be r1 plus ls cs r2 plus cs ls plus 1 divided by cs minus cs minus this is minus cs l squared s squared. Then this will be, so multiply na to sa taas, so therefore this will be lcs squared divided by r1 plus ls times cs r2 plus cs ls plus 1 minus cs l squared s squared. So we're going to expound this terms. So therefore, this will be LCS squared. So expound this one. So R1 by FOIL method. This is R1 times CS R2. So therefore this will be CS R1 R2 plus, so R1 times this one. So CS LS R1 plus this one, R1 plus 1 times 1. So this is 1 R1 plus next this one LS times CS. So LS CS R2. The next this will be this is C L squared S cubed plus LS. Okay, minus CS L squared S squared. So we're going to arrange these variables. So therefore this will be so I think this will be cancelled. This one cancel na. So therefore this will be cancel ni. Therefore this will be LCS squared divided by CSR1 R2 plus CS. This will be CLS squared R1 plus LCS squared R2 plus LS. So we're going to arrange the terms. So we're going to separate the S squared, the S, and the R1. So therefore, the S squared ni, S squared, S squared. So merge na to ang tanan S squared. So this is CL S squared R1 plus, by the way, so this is LCS squared plus this term, this is LCS squared R2. Then next this one, this is CS R1 R2, and then this one LS plus R1. So arrange na to ni. Then next is LCS squared. So we're going to extract so we're going to take out S squared. So this will be LCS squared. So this is R1 plus R2 times this is LCS squared plus we're going to take the S. So therefore this is L plus C R1 R2 S plus R1. So this is the transfer function of the circuit. This is I sub 2S, it's a function of V of S. So this is the transfer function.